Hello and welcome. This is Real Numbers video number 5, and today we are going to learn about fundamental theorem of arithmetic. In the last video, we did a quick recap of how do we do factorization of any number. I should say prime factorization of any number. Particularly, we took an example of number 8 and number 50. Today, let's do the opposite of that. What do I mean by that? So we start out by some prime numbers. So let's take the number 2, number 3, and number 5. These are three prime numbers. And now let's find out how many ways we can multiply these prime numbers and create new numbers. So for example, we can take the number 2 and multiply that by 3 and we get 6. So we create a new number 6. How about we multiply 2 and 5 and see what we get? Well, we know that 2 times 5 is 10, so we get another new number 10. This time let's multiply the number 3 and 5 and we get 15. So what we are seeing is we can create unique composite numbers. These are all composite numbers. Composite numbers are numbers that are not prime. Prime numbers are numbers that have factors of the number themselves and the number 1. Any other number is a composite number. Now we can also multiply all three of them together, and in that case we will get 2 times 3 times 5, which will be 15 times 2, simply 30. So as we multiply these numbers, we get unique composite numbers. Now let me also give you another extra flexibility and say each of the prime numbers, you can use them as many times as you want. What does that mean? So let's take a look at the number 2 times number 3. Now we know 2 times 3 is 6, but if you can use 2 as many times as you want, so you can do 2 to the power 2 times 3, which will be 4 times 3, which is 12. Similarly, you can do 2 cubed times 3. This will be equal to 8 times 3, which will be 24. So as you can imagine now, you can keep going, right? And similarly, you can also take different powers for 3. In other words, just with these two prime numbers, so 2 and 3, if we can take the power, if we can use the prime numbers as many times as we want, that means we can have infinite values here and we can have infinite values here. That means with these two numbers alone, we can create infinite numbers. So similarly, if we take combination of different prime numbers, that means, as you can imagine, we can create infinitely many numbers. So here is the big bold question. Can we create all composite numbers using multiples or multiplying different prime numbers? So let's take a look at the answer to that question. And as you can imagine, the answer is big yes. And that is what is known as fundamental theorem of arithmetic. So fundamental theorem of arithmetic states that every composite number can be factorized as a product of prime numbers in one unique way only, as long as we are not particular about the order in which the primes appear. That means, let's say the number 14. We can write 14 as 2 times 7. So is there any other way to write 14? Can we use any other two prime numbers to write 14? Can we say 3 times 5 or 2 times 5 or maybe 5 times 7? Answer is no. It has to be 2 and it has to be 7. Well, we can switch the order, but we don't care for the order. So this is what is meant by there is one and only one unique representation of multiples of prime number that gives a composite number. Now, we have not proved this, right? There is no proof, but this is by observation. So I will strongly suggest you can imagine any composite number. So let's say, let's make up some number. Well, we can take maybe 105, let's say. We know this is divisible by 5, so we can divide this by 5. So we will get 5, and 5 2s are 10, and 1. And we can break this into 3 and 7. So we can write 105 as 3 times 5 times 7, right? So this number, which is a composite number, we have broken it down into product of prime numbers. So what about, let's take a look at maybe simple like 72. We know 72 is 8 times 9. and 8 is basically 2 times 2 times 2, right? And similarly 9 is basically 3 times 3. So here we have 72, which is written as 2 cubed times 3 squared. So you can take a look at any number, right? Obviously, if you get a prime number, that doesn't count because prime number has only prime number and the number 1 as its factors. So all composite numbers can be uniquely expressed as product of primes. And this has tremendous implications and applications in the field of mathematics, and we are going to take a look at some examples of those in the next few videos. So if you have liked this video and if you want to receive such videos on a regular basis, feel free to subscribe to my channel and hit the bell button.